So I have fixed the current source. It turns out, or at least I hope I did. It turns out that I was, um, basically I wasn't given enough current uh, to the base. So I just kept reducing the resistors down to now I have two 1.5K resistors, which is probably um, less than what we need. Or yeah, so we would want to have higher there, but it seems to be working. So let's just turn it back on.
So I just wanted to quickly go over sort of what I was talking about in that last little segment. This is more what the total resistance could be for this part, because we like to have it that the current flowing through the biases here is 10 times what we would need flowing into the base. So that would be about 33.3K. So we probably could have got away with 30K, like 2 kilo ohm resistors, or maybe a little bit less than that. But the 1.5 kilo ohm ones, that's a little bit like that's basically that's 100 times more current flowing through than what we theoretically need. Um, yeah, so it's a bit smaller of a resistance than necessary, but it was working, so I just went with it.
So now we are back on 1.7. That now we have to replace the that's 1.5K. That is at the plus 5 volts. That's this guy here.
Okay, so I'm here just to go explain the changes that has happened with moving from from the 5, like the last one we were doing, which was basically differential amplifier, to the 5L.1.7 circuit. Stage 1 increased the gain of the bipolar differential amplifier. First circuit change to maximize gain, remove the 100 ohm emitter resistors. So right there. Remove them. Then test the consistency of it with a triangle as input. Second, to move the collector resistor from 10K to 1.5K. We actually remove this 10 kilo ohm resistor and put in a 1.5 kilo ohm instead. Then at the bottom of the circuit here, we have the final one of this side, which is right there. Have, like you see, I showed wave function 1, both of them, wave function 2 on just one of them, then channel 2 there and channel 1. This is a 10 kilo ohm resistor. I didn't write that in for some reason. And then there's our current source. Oh, so just here because in the video again, the bench video, it didn't really. It just said that we were gonna recalculate it, and it doesn't look like I actually went and tried to measure it at that point. So it didn't ask us to measure it. It asked us to recalculate it. But anyways, I estimated the differential right here, the 1.5 kilo ohms divided by 50 ohms. Now the reason I did that was that, or like how I got to that is that I said that this would have like a 50 ohm emitter resistor, like little RE. I just sort of guesstimated on it. So that's how I got there. And then same thing here. So 1.5 kilo ohms. 3 kilo ohms? Oh, yeah. I was just saying that it would be essentially the same as this. Not sure if that's right. Anyways, that's the common mode gain. Um, then down here, we're going to get in. This will be the next time that we see some analog discovery 3. As you can see here, I do have some readings. So here now, we went and we used a PNP resistor. Now on page 216 of Learning the Art of Electronics, you will see they have the pin numbers that you're supposed to be using because it's all using that same transistor array. Now, since I don't have that transistor array, I use just the 2N3906 transistor, and I have it just like right there. Then the 12K ohm is the same one that they have, and this is the current one. And then we measured the gain, said watch input and output of the CE to amplifier stage and measure this stage's gain. So let's go do that.
So basically, the gain is very high. Very high. Because, oh, see, I slammed it down too much. There it is. Woo! Okay. That took some doing. Yeah, yeah. That took some doing. But we have hit finally. So it appears to be going from 2 volts to minus 2 volts. And what we're driving it with is a 10 millivolt amplitude. That's so yeah. Basically it's a very high gain because well, let's see. 10.01 going to 2. 2 divided by 0.01. 200. Gain is about 200. Okay, so let's assemble the last stage of this op amp over here.
So I just wanted to say what changes to our little circuit that we've been building are done in section 5L.1.9, which happens to be the final adjustments to our circuit. So first, put in these two resistors. So this NPN one, 2N3904 right there. And this one here too, that's NP2N3906. And then I'll put this 10K resistor. That is the final circuit that they made. You can see that final circuit on page 217. Now at the end of it, it says feed a small sine wave differential signal to the input at a low frequency, 1 kilohertz or under. Watch input and output of this state. So we will do that.
So now we'll try this connection. Will force the amplifier to drive this input to the voltage applied at the other input, pin 5. As a consequence, we will trick your circuit into amplifier by about 11 times. Okay. So I think we did. So let's see. Go down back to there. Yeah, I think we did. So, oh, wait. So we are driving 5 amp or 5 millivolts. So that means we would expect 55 millivolts. Just expand this then to. So this is channel 2. That's our output. We're going from about 350 minus 250 to minus 450. So it's saying a little bit more. Yeah, so that is pretty cool. And we don't have to run around finding it anymore because it's not that high up a gain. That's the most cool part. Because that was ridiculous. Having to look for it so much. Yeah, that's about them. But it's so fuzzy. Here, let's go here. Now that we can try 20 mil. Just to try and give us some more signal here. That's about 100. So that's about 4/10 of a volt. So 11 times 2. So it's 2. Oh, wait. Yeah, no. Remember, because this is differential, we're only looking at the one of them. So it would be about 2 times. Yeah. No, that makes sense. We did get about 11 times. Yeah, that is pretty cool. So, yeah. Well, thank you. I will take a picture of this circuit for the video. And I guess I officially made an op amp